to here. All right, so this is figuring out which method to use when you're doing hypothesis testing. And so remember the two different things that you can look at are mu and p, right? So the population mean or the population proportion. And so remember that anytime you want to test a population mean mu, you're dealing with a quantitative variable. And then anytime you're dealing with a proportion, you have either a categorical or qualitative variable. Specifically, a discrete binomial variable, but that's fine. You can just say it's categorical. And so here are the two things, there's three things here that you could do, right? So if you know sigma, and if n is greater than 30 or x is normally distributed, then what function in your calculator are you going to use?
Z-test.
Yeah, z-test. And so it's z because you know sigma, right? And so let me put that in a different color. So z because you know sigma, test because you're performing a hypothesis test. But what happens if instead of sigma, you have s, and you still know that n is greater than 30, right? So what do you use instead when you don't know sigma?
T-test.
T-test. And so again, whenever you don't know sigma, so unknown sigma, that's when you use T, right? And then test, this is again because you're performing a hypothesis test. And then, yeah, so this note down here just says, if the second requirement is not satisfied, then you can't perform the hypothesis test, right? So that's why you always need to check the requirements first, is to make sure that you can actually go through this whole procedure and use these calculator functions, right? And so the last one, so that takes care of both cases when you're testing a mean. Then, so the second case is if you're testing your proportion. If instead of having mu, you have p, which function in your calculator are you going to use?
One prop z test.
Yeah, one prop z test, right? And so this prop z is coming from the fact that it's a proportion. And whenever it's a proportion, you use z-scores, right? So that's why there's a little note down here saying always use z-scores. And then the test is, again, because it's a hypothesis test. So are there any questions about just this overview of this section or this chapter of hypothesis testing? So this is essentially what that practice homework is determining if you're going to use z-test, t-test, one prop z-test, z-interval, t-interval, or one prop z-int, right? And so you just have to be very careful about the problem. And so really what it comes down to is just reading through the problem and making sure that you're reading through it correctly. And so that's what that reading assignment is for. But so if there aren't any questions, then let's start looking at this example. So it wants us to state which type of parameter is to be tested. And so the options here, so state which type of parameter. This is either mu or p. Those are the only two options. The type of test to use, so z, t, or prop z, right? And then perform the hypothesis test. So this shouldn't take too long, right? If it starts taking too long, we can skip the hypothesis testing portion for now. But so the first problem says that there's a simple random sample of 150 cars. 23 failed emissions testing, right? So essentially they failed their smog test. Can you conclude that the proportion of cars that failed the test is less than 20%? Use the alpha equals 0.05 level of significance. So are we testing? So the first thing we want to know is type of parameter. So type of parameter, which one are we testing, U or P?
P.
Yeah, it's going to be P. And what is the value of P for this example?
20.
Yeah, so it's either 20% or 0.20, right? So either one is fine, but when you put it into your calculator, make sure you're putting 0.2, not 20. But so yeah, so that's the first part. And then, so because we're testing a proportion, so type of test. So because you're testing a proportion, which one are you going to use? Z-test, t-test, or one prop z-test?
One prop Z test.
Prop z-test. And then perform the hypothesis test. And so to perform it, what we're going to do is we should just go through and put all of the steps that we would normally put, right? So the first step is to check the requirements. The first requirement is random, and yes, it says randomly selected or simple random sample. And then the next one is that n is greater than 30, right? So our requirements are satisfied. The second thing is to state the null and alternative hypotheses. And so here, remember H naught, so we already found the thing we're gonna put in our null and alternative hypotheses, right? We're testing to see if the proportion is equal to 0.2 versus what symbol should I put in my alternative hypothesis? Less than, greater than, or not equal to?
Less than. Less than.
Less than, because it says less than right here, right? And so these are my hypotheses. So that's the second step when you're performing a hypothesis test. And then the third step is to determine, so here, let me put a little like, how do I want to organize this? So here, I'll put the third step up here. So either choose between the critical value, method and p-value method. And so for this one, we'll use the p-value method. And then I'll do an example with the critical value method down below when we do the next one where we can use the the critical value method. And so we already said that we're going to use one prop z-test. And so, oh, get out your calculators. Mine should be here. That's right here. And so make sure you can get the same answers as me. But so when I do one prop z-test, it asks me for p naught. We already know that that's 0.2. And then it asks me for x. So in this case, what is my variable for, or what is my value for the variable x?
23.
Yeah, it's going to be that 23 out of n, which in this case is 150. And then what we put in at the very bottom is the less than p naught. So here 0.2, 23, 150, less than p naught, calculate. And so here you get a p-value. So after you put all of that in, you get a p-value of 0.077. And so then the fourth step would be to make a conclusion. And so here, for the conclusion, do we reject or not reject? So the p-value is greater than alpha. because this is 5% and this is 7.7%. So yeah, what am I gonna do?
We reject.
No, so yeah, you have it backwards. So whenever the p-value is greater than alpha, that's when you're not gonna reject. And so if I were to draw it out with like the critical region method, then what this is saying, so remember critical region is the unusual values. And so here's my region of unusual values. And the area of this is 5%. Actually, this is a right or a left-tailed test, so I'm on the wrong side. So here is my critical region. And so I know this is 5%, but then my p-value is saying now that I'm including things that are not unusual, right? Because the percentage is greater, that means I have values that are not unusual. So all of these values right here are perfectly like acceptable values, I guess. They're not unusual, which means that it wouldn't be so unreasonable to say that the proportion is actually 20% and not less than that, right? And so here, you're going to not reject. So do not reject H naught. And then the last step would be an interpretation, but I'm kind of running out of room. And so the interpretation here would be there is not sufficient evidence to support the fact that the proportion of cars that fail the test is less than 20%. So yeah, do you guys have any questions about this one? Does this make sense? Did everybody understand the p-value method? Oh, calculator's falling. Thank you. Oh. Okay. So let's move on to the next one. And if there's room, we'll put the interpretation for that one. But so here, let me just kind of, I guess, for the interpretation, you would say there is not enough evidence to support that it is less than, oh, whoa, that was weird, less than 20%. Okay, so if we look at the second one right here, it says a simple random sample of size 15 has mean x bar equals 27.72 and standard deviation s equals 8.21. And it tells us that the population is approximately normally distributed. So, and then it asks us if we can conclude that the mean differs from 35. And it wants us to use alpha equals 0.01. So here, let's just kind of take note of all the variables that I'm given. So I'm given n equals 15, x bar equals 27.72, s is equal to 8.21. And then what value or what variable is this 35? Like what symbol does it get?
Mu.
Yeah, it's going to be mu. So mu equals 35 and then alpha equals 0.01. And so the first thing it wants us to do is figure out what we're testing, either mu or p. And so here, since we know that mu is equal to 35, we're testing mu. So type of parameter, so that's the first question. Type of parameter is mu. And then based on the variables that we're given, which calculator function are we going to use? Z-test, t-test, or one prop z-test?
T-test.
T-test, because of which variable? Which one is causing us to have to use t-test?
S.
Yeah, this S right here, right? So because we're given S and not sigma, you have to use t-test, and it looks kind of like a J. So yeah, t-test. And then we can do the same thing where we actually perform the hypothesis test, right? So you need to do the requirements first. Oh, wow, that is not how you spell requirements. Okay, requirements. So the first one, random, that's taken care of. But the second one, so the second one says that you either have n is greater than 30 or you're told that it's normal. Is either one of these satisfied?
N is greater than 30.
No, look at what n is equal to here. Right?
Sorry, I was looking at you.
Oh, okay, yeah. So here, if n isn't greater than 30, then we better be told that it's normal. Am I told that it's normal anywhere?
Yes.
Yeah. And so the second requirement is satisfied as well. Nope. All right. So the second thing that we're going to do is the hypotheses again. So H naught, we already know mu equals 35, but what is my alternative hypothesis going to have now? Less than, greater than, or not equal to?
Not equal to, different.
Yeah. Good job, Cass. You got it right. All right. So, and then the third step is, so up here I had said that the third step was to choose between the critical value method and the p-value method. Do I have a choice here when it comes to using t-test? Do I get to choose?
No.
No, I have to use which method? Critical value or p-value?
P-value?
Yeah, I have to use the p-value method. So p-value method, and then here you have no choice. And so when you go through and you put all the information into t-test, because we've already said that that's what we need to use, you're going to put mu naught is 35, x bar is 27.72. This is also capital SX, right? So little s, so 8.21. N is 15, and then not equal to. So calculate. Here you get a p-value equal to 0.004. And so now we can make our conclusion. So we're comparing it to a significance level of 1. And this is, if I move this over 2 spaces, this is 0.4%. So is the p-value less than or greater than alpha? So yeah, based on these percentages, which one of these is bigger, P or alpha? Where's the other percentage? This 1%.
P?
Yeah, no, it's going to be alpha, right? Because this is 1%, this is less than 1%. And so here, like this isn't even 0.5% yet. And so here you have that p-value is less than alpha. And so when your p-value is less than alpha, what are you going to do? Reject or not reject?
Reject.
Yeah, that's when you're going to reject H naught. Oops. Whoa, okay. Sorry, my cat's jumping all over the place. All right, and then we can put like a rough interpretation. And so here we can say there is enough evidence or sufficient evidence to conclude that the population mean differs from 35. And then you would, yeah, at the 1% significance level. So are there any questions about when you should use z-test versus t-test? Because here we used t-test, right? So is everybody okay with this one? Yeah, so if you try using the critical value method the way we were doing it when we were using z-test, so first it kind of requires you to, here, the best way I can explain it is, this is your normal curve, right? And for the critical region method, it starts out with you finding this z-score. But z-scores are found if you didn't have a calculator, the way you would calculate it by hand. And so you guys have calculators, so you don't have to worry about this, which is why it's a little bit harder for you to see why you can't do it this way. But this z-score would be equal to x bar minus mu divided by sigma over the square root of n. And if you don't have sigma, you can't find z. You can't find your critical value. And so there is a critical value that you could use, but it's not a z-score. And so that's why you can't use the critical value method, is because its critical value isn't a z-score. And I didn't want to show you how to find those critical values. But so we're just going to say that for our class, you can't use the critical value method here. It has to be the p-value method. Does that make sense, Bianca? Okay. So yeah, let's look at question 3. So this is the last one, right? And then Wednesday we'll talk about confidence interval review. And so if we look at this last one, we're told that a simple random sample of size 65 has mean 38.16. The population standard deviation is known to be 5.95. And can you conclude that the mean is less than 40? Use alpha equals 0.01. So what am I testing here? So type of parameter, is this going to be mu or p?
Mu.
Yeah, it's going to be mu because you're told that the mean, right? So mean is going to be mu. So you actually know that mu is 40 in this case, right? So I'm also given another variable. What is this 5.95? I know it's a standard deviation, but is it sigma or is it S?
Is it S?
So look at right here. So whenever you're told population standard deviation, what symbol is that?
Sigma.
Yeah, that's sigma. And so
is that what makes it different when reading the problem from trying to figure out how it's S?
yeah, so if you look up here, well, this is a bad example, part B, because it actually gives you the variable S. But for instance, let's say that it didn't, like if it just didn't have that S equals part, like it just said 0.82 or 8.2 right there, then you know it's a sample standard deviation because it's giving it to you in one sentence, right? So because it's in the same sentence as the sample mean, you know it's the sample standard deviation. Does that make sense?
Yes, it clears a lot more up.
Yeah, and then this one, it's in its own sentence, like it's off on its own little world. And so, and usually if you're given population standard deviation, it'll specifically say population standard deviation, whereas this one won't specifically say sample or population. It'll kind of just be implied that it's a sample. So yeah, that S is there. But so yeah, that's why you should practice the reading one, the reading assignment that's up there on My Open Math, because I don't ever give you these variables. Like I took all of those out just to make it a little bit harder. But I mean, I think it's better. But okay, so yeah, here, this is sigma, right? So sigma equals 5.95. And because I know sigma, which test am I going to use? Z-test, t-test, or one prop? Z-test. Yeah, z-test. And so here, if we actually perform the test, we need to check the requirements. They're both satisfied, so I'll just kind of write this down really quickly. N is greater than 30. It's random. It's not very interesting anymore. Okay. And then your hypotheses. So we already know mu is equal to 40. But my alternative, is that going to be less than, greater than, or not equal to?
Less than.
Less than, because it specifically says less than right here. And then now I'm going to go and I'm going to put everything into z-test. Oh, wait, but first, so here, again, I get to choose between critical value method and the p-value method. And so I'm going to do the critical value method, just so you get to see both. And so for the critical value method, what we're going to do is you're still going to use, well, before you find z-test, you have to find your critical value, right? So z sub c. How do you find z sub c again? So remember, this is the value that separates your critical region.
Inverse norm?
Yeah, it's going to be inverse norm. And so if we were to draw this picture out, since alpha is 0.01, what this looks like is it's a left-tailed test. So here's my critical region. I'm trying to find this value z sub c, and I know that this is 0.01. So in your calculator, when you do inverse norm, what number should you put first? Yeah, that 0.01. And then here you're just going to put your mean and your standard deviation for the standard normal curve. So do you guys remember what two values go next? What's the mean and standard deviation for the standard normal curve?
0, 1.
Yeah, 0, 1. And so let's do this. So second distribution, inverse norm, 0.01, 0, 1. And so here you should get negative 2.33 as your critical value. So this is negative 2.33. So basically your critical region is all of the values less than negative 2.33, right? So if you guys remember back to when we first started doing critical regions, we found intervals, right? So it goes from negative infinity all the way up to negative 2.33, right? So these are the unusual values. And then once you figure out what that critical value is, you're going to take your sample statistic and you're going to convert that to a z-score to figure out if that's an unusual value or not, right? And so you do that, and so here, I'll put that here. So the fourth step is to find the z-score for your sample statistic, which in this case is x bar, equaling to 38.16. And so here, you're gonna find this using z-test. And when you put everything into z-test, which variable is it that you're gonna have here? What's your z-score that you care about? You guys remember? 40, 5.95. So yeah, after you're done, right, it gives you z, p, x bar, and n. So which one of those is the value that I'm looking for here? And what is it called? Yeah, wait, say that again? Sorry.
Just said z.
Okay, yeah, it's z. And so here you get z equals negative 2.49, and then a lot of other numbers. And what is this called again? Do you guys remember? What is the definition of this, the name of this? It's something statistic. Yeah, test statistic, right? So I want to say on the exam, it's going to ask you for the like some test statistics, and it's not going to tell you that it's Z. You have to know that it's looking for Z, right? And so now what you do with your test statistics, so step 5 is compare Z sub C and Z. And so you want to know, is your test statistic inside your region of critical values? And so here's negative 2.33. Your test statistic is less than that, which means it's going to be to the left of it on the number line, right? Because here, like, it gets more negative the left you go, the more left you go. And so negative 2.49 is like right here. So because it's in our region of unusual values, Z is considered unusual. So what do? Do we reject or not reject? Yeah, you're gonna reject H naught. And then the last thing is your interpretation. So this is, there is enough evidence to suggest that the mean is less than 40. Okay, so yeah, that's the critical region method. Real quick, I'm going to compare it to the p-value method, and I'm gonna add that onto my picture. So the only thing that the p-value does here is the p-value is the area of this blue piece. And so we didn't actually find the p-value, but that's what it would look like, right, if you did find it. And so I'll erase all of that so it's not so confusing. Here, I'll just undo it. So yeah, oh, perfect timing. Do you guys have any questions about this? Hopefully this helps for your exam. Hopefully you all get 100% now.